Hi guys, welcome to JIK 224 e-Kuliah series. I'm Dr. Sumia Sabah. In this video, this is the first video covering chapter 2, which is Stereochemistry. So in this first video, we will cover the Stereochemistry, the introduction of Stereochemistry, and what is Stereochemistry. So we will recap back some of the isomers that you have learned so far. And we will introduce to you a new subject, which is the stereoisomer. So upon completion of this topic, you should be able to recognize structure that have isomerism and identify the relationship between the isomers. Okay, what is stereochemistry? Stereochemistry actually refers to the three-dimensional structure of a molecule. As a consequence of stereochemistry, apparently even minor differences in their 3D structure can result in different properties, okay, of the two structures, and this will give an impact to their reaction. We can observe this by considering starch and cellulose, which are both composed of the same repeating unit. So starch and cellulose are actually an isomer, a pair of isomer. They have the similar molecular formula, which is C6H10O5. So this is their individual unit. So they have the repeating units because they both are a polymer. So this is their structure. This is the cellulose structure, 3D structure of a cellulose. And this is a 3D structure of starch. So cellulose actually consists of an extensive three-dimensional network held together by hydrogen bond, while the starch polymer is composed of chain that wind into a helix. Okay, so they are stereoisomers because only the three-dimensional arrangement of the atom is different. Okay, one is have a almost a planar structure, while the other one is in helix structure. So apparently, even minor differences in the 3D dimensional arrangement of atom can lead to very different properties on starch and also cellulose. Okay, for example, because of these differences in the 3D structure, human can metabolize starch for energy, but we cannot digest cellulose. Just because of these small differences, it leads to a very big different properties. Okay. So what is isomer? Isomer are different compounds with the same molecular formula. Okay. Let's say just now we discussed about cellulose and starch. Cellulose and starch have different 3D structure, but their molecular formula is the same, which is C6H10O5. Okay, so the two major classes of isomers are constitutional isomer and stereoisomer. So we will focus first on the constitutional isomers, because most of the isomers in constitutional isomer you have looked at in the past, but stereoisomer, I think this is a new topic for you. So later in the later videos, we will focus more on the stereoisomers. So what is constitutional isomer? It is also known as structural isomers. It is isomers that have the same molecular formula but differ in the order in which their atoms are bonded together. Okay. Constitutional isomers have different IUPAC names, same or different functional groups, different physical properties, and different chemical properties. So because of these differences, okay, it leads to a big difference in their physical and also their chemical properties. So this is a skeletal. The constitutional isomer can be different in terms of its skeletal, or also known as skeletal isomerism, or in terms of their position, okay, or known as positional isomerism. Okay, so here we have a 4 carbon, which is a butane, okay, but it has a similar molecular formula, which is C4H10. Okay, but we can arrange them into a branch. Okay, now we have 2-methyl propane. Okay, propane, because we have the 3 carbon as the main background. So now we have propane with a substituent, a methyl substituent on carbon number 2. So this is also known as 2-methyl propane. Okay, we can also differentiate constitutional isomers in terms of their position. So here we have a phenol, backbone of phenol, and we have a nitro groups at carbon number 2. So this is called auto-nitrophenol. Okay, but the nitrophenol, we can attach them at carbon number 3 or 4. Okay, so in this case, we are calling it para-nitrophenol. So there is a difference in terms of their position, but the molecular formula is the same. Okay, what is stereoisomers? Stereoisomers have also similar molecular formula and bonding sequence, but differ in the way the atoms are orientated in a space. Okay, it's different in the way we arrange the atoms. Okay, it has identical IUPAC names except for a prefix like cis or trans, and always have the same functional groups. So that's the difference between constitutional isomer and stereoisomers. Okay, and it differs in configuration. It's particular in terms of its 3D arrangement. So there are a few types of stereoisomer, 2 types actually. We have enantiomer, where the 2 compounds that are non-superimposable mirror image of each other, and diastereomers, that is 2 stereoisomers that are not mirror image of each other, or we call it it has a superimposable mirror image to each other. And also under the diastereomers, we have the geometric isomers, which is the cis-trans isomer. Is also one of the diastereomers. So in the later video, we will discuss more on what is the non-superimposable mirror image and superimposable mirror image. So here's the difference between constitutional and stereoisomers. Okay, in constitutional isomer, here we have a molecular formula of C6H14. We can arrange them as 2-methyl pentane or 3-methyl pentane. Either way we name it or we draw the structure, we still have the same molecular formula. Only the names is different. While for stereoisomer, we also have the same molecular formula, which is C7H14. But here we can name this compound as cis-1,2-dimethyl cyclopentane, while this one is trans-1,2-dimethyl cyclopentane. So cis is when you have the substituent on the same side, while for trans we have the substituent on opposite side. Okay, so we have the same molecular formula, same name, except for the prefix, and also in difference in terms of where the substituent is located. Okay, like for cis is in the same direction and trans is in opposite direction. Okay, when we compare the structure or the isomers, we can first, for a compound to be an isomer, it has to have same molecular formula, and then we can divide them into 2, either constitutional isomer or stereoisomer. Okay, and then if the compound is stereoisomer, we can divide them into 2, which is enantiomer, that has a non-superimposable mirror image, and diastereomers that have superimposable mirror image. And then from diastereomers we can divide them into 2, which is the cis-trans isomer, or also known as geometric isomers, and other diastereomers. Usually this involve 2 or more chirality center. Okay, so this we will look at in the following videos. Okay, let's look at an example. Classify each pair of compound as constitutional isomer or stereoisomer. So you have to remember that constitutional isomer have atom bonded to different atoms. Okay, it's difference in terms of the arrangement of the substituent, while for stereoisomer it differs in the 3D dimensional arrangement only. Okay, and also in the names, because it has similar IUPAC names, the difference is only in the arrangement in the 3D structure. So we have these two structure. What you can do first is that because it's an isomer, so you know that it has a same molecular formula. Okay, now the only thing that we see here is the difference in the substitute. Okay, so this is 2,3. We name them as 2,3 dimethylpentane. Okay, pentane, we have 5 carbon in the main background, and then we have 2 substitute, carbon number 2 and also carbon number 3, which is dimethyl. And then for this one we have 2,4-dimethylpentane. We have the substitute carbon number 2 and also carbon number 4. So we have different connectivity of atoms and also different names. So we know that this is constitutional isomers. Okay, what about this one? We can try to name the compound first. This is a cyclo groups. Okay, so here we have a 4-membered ring. Okay, 1, 2, 3, 4. And this one we have a 3-membered ring with hydroxyl group attached to carbon number 1. Okay, so we also have different connectivity of atoms. So this is also a constitutional isomers. Another example is that here we see a 4-membered ring. Okay, both of them 4-membered ring, but one of the substituent is in different position. One is at carbon number 1 and one is at carbon number 2. Okay, and it's also in 3D structure but in opposite side. Okay, the dark wedges here indicates that the substituent is pointing towards us, while the dashed line here indicates that the substituent is further away from us. It's at the back, okay, facing our back. So we have also different connectivity of atoms. So it is also a constitutional isomer. Okay, what about this one? We have 2 dark line pointing towards us for this molecule, and here we have 1 dark line pointing towards us and 1 dashed line pointing at the back. So this is a trans isomer, while this one is a cis isomer. So both are 1,2-dimethyl cyclobutane. So they have the same name except for the prefix cis and trans, but the methyl groups are orientated differently. So this is a stereoisomer. So in the later video, we will discuss more on the stereoisomers, what are enantiomer and diastereomers, and towards the end of this chapter, we will recap back what is the difference between a constitutional and stereoisomers, and what if I give you a compound, you have to indicate whether it's an identical structure, constitutional isomers or stereoisomers. So later at the end of this chapter, we will recap back on this chapter. Okay, so but I want you to learn more on and understand more what is the stereoisomers. Okay, so as a summary, stereochemistry is the study of the 3-dimensional structures of molecules. The 2 major classes of isomers are constitutional isomers, where the isomers that differ in the order in which their atoms are bonded together. Stereoisomers, which is the isomer whose atoms are bonded together in the same order but differ in how the atoms are orientated in the space. There are 2 types of stereoisomers, which are enantiomer and diastereomers. Okay, this is the reference. If you have any question, do contact me at my email address, and thank you for listening.